Hello, my name is Will Simonson, and today I'll be going over Physics Lab 4, Oscillations. So the instructions and purpose of this lab is to analyze the motion of a mass oscillating on a spring while swinging in an arc, and to use a tracker to gather information about its position over time, and to build a computational model of the motion to analyze the changing energy. The preview of results are the observed data and the predicted data turn out to be very similar. This could be that the video used is universal, which means there is less error. So the only error that is found is the difference in using the tracker. The system is the mass, spring, and the earth. There are no surroundings. The work is equal to 0, and the change in energy is equal to 0. So fundamental principles, the energy principle is the energy change equal to the change in kinetic plus the change in potential, spring, or gravitational. These are the formulas for the different energies, and the spring force is the spring constant times the change in length. So oscillation is t squared equals 4 times pi squared times mass over k. And Newton's second law is F net equals mass times the change in velocity divided by the change in time. The net force acting on the object is found by using the mass, the gravitational force, and the spring force, where the equation was shown in the last slide. And the initial position is what we use in tracker, which was negative 0.115 in the x, negative 0.643 in the y, and 0 in the z. The spring constant is 6.83, and the LO is 0.123. So the tracker, it shows that it changed the x in the negative direction at 2.857 times 10 to the negative 2 meters. This is like in a pendulum. And the y direction, it's moving in a spring manner, and the y was at negative 0.714. So here's the code. As you can see, inputted the mass of the ball and the initial conditions which were stated earlier, and then use the spring constant and the relaxed length of the spring to calculate the energy of the system, which is shown in the next code. As you can see, the force of the spring was used to update the velocity, and this velocity was able to find the kinetic energy, and also based on the heights and the displacement of the ball compared to the spring, the energies for potential energy of the gravity and potential energy of the spring shown on the right side were able to be calculated. So for the results, you can see that the potential energy graphs, the gravitational and spring, oscillate inversely to each other. The change in kinetic energy is very close to 0, and it's also oscillating. And the total change in energy, which was also stated earlier, is going to be 0 the whole time, because the gravitational and spring energies cancel each other out, and so does the kinetic energy. So in comparison, both are very similar, as stated earlier, and this is because there is the same video used, and the only differences would be human error in the tracker usage. So what does it mean? The energy principle is satisfied because the potential energies, gravitational and spring, are oscillating in the same period but in opposite directions. K is shown increasing and decreasing accordingly to result in a 0 energy change in the system and surroundings. Human error accounts for graph differences, as stated earlier. Comparing period of oscillation for both x and y position data. So x was 1.6334 seconds of oscillation, and y was 1.5004 seconds of oscillation. This is probably because periods are not the same, which is because of gravity and the fact that the x period, x is moving like a pendulum, as stated earlier, back and forth, side to side, and the y direction is moving like a spring, up and down, and that kind of angle and trajectory, which means that they are not affected by the same forces, and this also shows differences in the tracker's estimation. Thank you.